Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the second derivative for these equations. Now the second derivative means the derivative of the first derivative. So the first step here is to find the first derivative for these equations and then find the derivative of the derivative. So let's start with the first equation on the left side. So it is y equals x to the power 10 plus 3x to the power 6. Now the first step here is to find the first derivative, which is equal to y prime. So we have to find the derivative of the two terms on the right side. So the derivative of x to the power 10 can be found using the power rule. So we'll move the exponent to the front and we'll subtract 1 from 10 plus, now we'll use the power rule again for the second term. So 3 is the coefficient, so it will stay as it is, times 6, and then x exponent 6 minus 1. So now we can simplify this expression. So y prime equals 10 and then x to the power 9 plus, now 3 times 6 is 18 and 18 x to the power 5. Now we can find the derivative of this derivative and that will be our second derivative. So the second derivative can be written as y double prime equals, so we'll start with power rule for the first term. So 10 is the coefficient, so it will stay as it is, and then we'll move 9 to the front, and then x exponent 9 minus 1 plus, now we'll do the same thing for the second term. So 18 times 5 and then x exponent 5 minus 1. Now we can simplify this expression. So y double prime equals, so 10 times 9 is 90 and then x exponent 8 plus, then 18 times 5 is equal to 90 and x exponent 4. So this should be the second derivative for the first equation. So we are done with the first problem. Now we can work on the second function. So I'll use a different color. So the second function is, so f at x equals square root of x. Now the first step here is to change the radical into a rational exponent before we find the derivative. So we can rewrite this as f at x equals x exponent 1 over 2. Now we'll find the first derivative for this equation. So that will be prime of f at x. And we'll have to use the power rule. So we'll move the exponent to the front, so 1 over 2, and we'll subtract 1 from the exponent. Now we can simplify this expression. So prime of f at x equals 1 over 2 and then x exponent negative half, because half minus 1 is equal to negative half. Now we'll find the derivative of this derivative equation and that will be the second derivative for this equation. So we'll write that as the double prime of x. So that will be equal to 1 over 2. So we'll use the power rule again. So we'll move the exponent to the front. So negative 1 over 2 and then x, and we'll subtract 1 from the exponent. So 1 over 2 minus 1. Now we can simplify this expression. So the double prime of f of x equals, so 1 over 2 times negative 1 over 2 is negative 1 over 4. And then for the x term, we can subtract 1 from negative half. which is equal to negative 3 over 2. Now we can move this x term to the denominator to make the exponent positive, because in the final answer we cannot have a negative exponent. So the answer will be 1 over negative 1 over 4 and then x exponent 3 over 2. So this should be the final answer for the second derivative of the second equation. Now we can analyze the third equation. So the third equation is y equals 1 minus x squared. So we'll start by finding the first derivative, which will be y prime. And here we have to use chain rule, because this expression is made up of an inner function, which is 1 minus x, and then the outer function, which is the exponential function with exponent 2. So we start with the derivative of the outer expression, and for that we'll use the power rule. So we'll move the exponent 2 to the front and then subtract 1 from the exponent. So we get 2 minus 1 times the derivative of the inner function, which is 1 minus x. So the derivative will be 0 minus 1. Because 1 is a constant, so its derivative is equal to 0. Now we can simplify this expression. So 0 minus 1 is equal to negative 1, and negative 1 times 2 at the front will be negative 2. So we get negative 2 parentheses 1 minus x exponent 1, but we don't write 1 as an exponent. Now we can find the derivative of this equation, and that will be the second derivative. So that will be y double prime equals, now here we just have to find the derivative of the expression in the parentheses. Negative 2 is a constant, so it will be 0 minus 1. So now we can simplify this expression. So 0 minus 1 is equal to negative 1. So we just have to do negative 2 times negative 1, which is equal to 2. So in this case, we got a numerical value for the second derivative of this function. So now we can work on the fourth one. So we are given the equation as y equals 4x exponent 3 over 2 minus x exponent negative 2. So we'll start with the first derivative, which will be y prime equals. So for the first term, we'll have to use the power rule. So it will be 4. So 4 is the coefficient, so it will stay as it is, times the exponent 3 over 2. And we'll subtract 1 from the exponent. Minus. So for the second term, we'll have to use the power rule. So we'll move the exponent to the front, and then we subtract 1 from the exponent. Now we can simplify this expression. So y prime equals, so 4 times 3 over 2 is equal to 6. And then x exponent. Now 3 over 2 minus 1 is equal to 1 over 2. And then the second part, so minus negative 2 will become positive 2. And then x exponent, and negative 2 minus 1 is equal to negative 3. Now we can find the derivative of this equation, and that will be the second derivative. So we get y double prime equals, so for the first term we'll have to use the power rule. So 6 times 1 over 2, and we'll subtract 1 from the exponent, and then plus. So in the second term, we'll have to use the power rule again. So 2 stays as it is, and then we move negative 3 to the front, and then we subtract 1 from negative 3. Now we have to simplify this expression. So 6 times half is 3, and then x exponent. So half minus 1 is equal to negative half. And then 2 times negative 3 is negative 6. And x exponent, negative 3 minus 1 is negative 4. Now we should make these exponents positive by moving the x terms to the denominator. So the double prime of y equals 3 over x exponent half minus 6 over x exponent 4. So this can be the final answer for the second derivative of this equation. And we can also write the x exponent half as square root of x. So that can also be our final answer. So you can write the answer either way. Over 6 over x exponent 4. So these are the steps you have to keep in mind to find the second derivative of a given equation. So we first have to find the first derivative, and then the second derivative is the derivative of the first derivative. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.